Today we're going to be talking about relations and functions, talking about what a relation is, what a function is, how they compare to each other, and relate to each other, and things of that nature. So first we need to know what relations are. So a relation is a set of ordered pairs. Ordered pairs, what does that mean again? So x, y, all right? The blank of a relation is the set of first coordinates. So if you're looking at the ordered pair, the x coordinates, the first number that you see, is going to be the domain of whatever the relation is. That means that the blank is the second set of coordinates. So that means the y values, if you're looking at this, all of the y values are going to be the range. Now, you have to keep track of which one's which. The way I do it is domain comes before range alphabetically. X comes before y alphabetically. So domain is the x's and range is the y's. They go alphabetical order. Okay? Now, in order to write these things, let's talk about how we're going to do that. So to list domain and range, we're going to do a few things. So we're going to use what we call, or what I call, fancy brackets. That means that we're going to do these things. And you're going to do your best in drawing or, writing those fancy brackets. That's okay. The next thing we're going to do is we need to make sure that it's from least to greatest. So the elements in these are from least to greatest. And there can be no repeats. So a number might happen more than once in the domain or in the range, but we're not allowed to repeat it when we're actually going through and performing or writing out what those things are. So let's see these things in practice. We can represent a function, or a relation in a number of different ways. And here's two of them that you've seen in the past. So this is just a table where it lists out the values or lists out the points. So we have 4, 3, -2, 1, -1, 3, 4, -2, and -1, 1. And this could be, points that are plotted on a graph. They're not necessarily connected in any way, shape, or form. It's just dots. So this could also be represented on a graph. So our domain is going to be all of our x coordinates, but we're going to make sure that we're listing them from least to greatest in fancy brackets without repeating. So I'm going to draw my left fancy bracket, and the smallest number out of all of these is going to be -2. And I put a dot there so I make sure that I take care of it. I don't forget it. The next smallest number would be -1. And I see that written twice. So I'm only going to write that once in my domain, even though it occurs twice. And then and then 4 is our last domain value. And we have all of those domain values taken care of. So we're ready to move on to range. And range is just going to be the other coordinate, the y coordinates, again listed in order from least to greatest in fancy brackets. So -2 is the smallest. The next smallest number would be a +1. Even though it happens twice, we only list it once. And +3, again, happens twice, but we only write once. So that's what you do if it's in a table. The x's on the left side are going to be your domain. The y's on the right side are going to be your range. So what happens if they're listed in a set of ordered pairs? This right here is a relation, a set of ordered pairs. So our domain is the x's. So that means that we're looking at these first coordinates and listing them in order from least to greatest, not repeating. So we would have -2. Next would be 0. Next would be 5. And last would be 6. So none of those repeated, so I'm not going to repeat any of, there is nothing to repeat. We just list them all out. And then the y coordinates of this are going to be the range. And just like I'm doing, if you want to use different colors to help make it make a little bit more sense, that's fine. So we would start with -3 is the smallest. Then comes -1, 3, and then 4 is the biggest number. And so that's looking at a relation as a set of ordered pairs this way, listed out. That's going to be domain and range, okay? X's are domain, range is your Y values. So let's see what happens if we look at another way to model these. So we can use what's called a mapping diagram. And for a mapping diagram, you're going to be given a relation, a set of ordered pairs, and then we're going to have to write our domain and our range. And you're going to see two ovals here. Sometimes you might see them as rectangles, and that's fine. But the domain is going to be the left bubble, and the range is going to be the right. And this goes along just with our domain is the X's. It comes first. It's on the left, and range is the Y's. It's on the right. All right. So first, we're going to find domain. That's going to be the first coordinates of these, and we're going to list them in order from least to greatest, which they already are. So we would stack them, 11, 12, 13, 20. Again, we're not going to repeat any numbers at all. Same thing's going to happen with the range. So -2 is the smallest. That repeats. I'm not going to repeat it again. Then we have -1 and +7. So there's the domain and range. The mapping diagram comes from, you're going to show where each domain value is mapped to in the range. So since we have the point 11, -2, we're going to draw an arrow from 11 to -2 because we started with this domain value of 11 and we ended with the range value of -2. Going to the next point, we have 12, -1. So we draw an arrow mapping 12 to -1. We're going to map 13 to -2, since that's the y coordinate. And 20 is going to get mapped to 7. So this is what a mapping diagram looks like for a relation. Okay? So here's another relation. We have -2, -1, -1, 0, 6, 3, and -2, +1. Those are our ordered pairs. We're going to make a mapping diagram for that. So domain, then range. Domain goes on the left. So here we have -2, -1, and 6. And so you don't have to underline them if you don't want to. You can just do it like this. That's okay. Our range is going to be -1, 0, +1, and 3. So domain, left, range, y is on the right. Okay, so now we're going to map them. -2 maps to -1. -1 maps to 0. 6 maps to 3. And -2 maps to a +1. Now that we know what relations are and a way to look at them, we are going to talk about functions. Okay. And we're going to see a lot of those same types of things and how we're able to determine whether things are functions or not. So a function is a relation, so that set of ordered pairs, that assigns exactly one value in the domain to each value in the range. What does that mean? Exactly one value in the domain to each value in the range. That means that no x value is allowed to go to two different y values. Okay? No x value is allowed to go to two different y values. So our x's can't repeat in this. All right, so we're going to determine if a relation is a function using a mapping diagram. So we have domain, we have range, we have our list of points here. I'm going to go a little bit faster through this one since we know how to make mapping diagrams. So we would have -4, 3, 8, and 9 as our domain values. Our range, we would have -2, 0, 1, 2, and 3. And then we're going to map those. So 3 maps to -2, 8 maps to 1, 9 maps to +2, 3 maps to 3, and -4 maps to 0. So everything has to have a counterpart to go with it. There shouldn't be anything that's left unmatched because we've used the domain and range values from the relation given to us. So looking at this, we're trying to see, do all of these x values go to just one range value? So 4 only has one arrow coming from it. 3 has 2 arrows coming from it. Is that allowed? In order to be a function, you can only have one domain value going to each range value, meaning this would be not a function. Okay, this would not be a function. All right, so next up is to see this one. So we have domain and range. Again, we have our list of points. Our domain here, 2, 5, 6, 6.5, and 7. So your numbers in your domain and range can be fractions or decimals, and that's okay. So our range values are going to be -1, 0, 2, and 6. And mapping these, we'll go ahead and draw our arrows. So these are just one-sided arrows that go from the left, from the domain, over to the right, which is the range. So then 6 gets mapped to 2, 2 gets mapped to 6, and 5 gets mapped to -1. So remember, we're looking for the x's to be repeating in this process. And so 2 only goes to one place, 5 goes to one place, 6 goes to one place, 6.5 goes to one place, and 7 goes to one place. So this would be a function. You're looking for 2 arrows to be coming from a domain value, or you're looking at the x coordinates in the relation and saying, yes, they repeat, or no, they don't. Okay? Well, how can we look at this graphically? Okay? So we're going to use something that's called the vertical line test. Okay, the vertical line test. We're also going to call this VLT. You can call it that, vertical line test. It says if any vertical line passes through more than one point on the graph, the relation is not a function. Okay, so let's kind of talk a little bit about that for a second. If a vertical line, what does a vertical line look like again? So it's going to be something that's going like this, straight up and down. If a vertical line touches a graph more than once, it's not a function. What does that mean? That means that the x value of something would repeat. Okay, that means the x value would repeat, and if it repeats, we know it's not a function. So looking at these, one way to do this is to physically draw vertical lines. Right? If I'm looking at any of these vertical lines that I'm drawing, and obviously there's more that happen in between these. If I look at any of these vertical lines, how many times does each of them cross the parabola that was given to us, the graph? So it just touches once, 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 once. Since all of those just touch once, this would be a function. Okay, what about this one? Or this one, or this one. I want you to take a second and think, which ones do you think would be a function or not a function? Again, you're looking for x values to repeat. Okay? So here in this one, if we were to, another way instead of drawing in all those vertical lines is just to use your pencil, your pen, your finger, something like that, where you're just going across and looking at how many times is the graph touched by this vertical line. So as I go across this, will it ever touch more than once? And the answer is no. So this is also a function. Now, looking at something like letter C, here, if I make the vertical line right there, it touches every single one of those points. It shares every single one of these. We have 3, 0, 3, 1, 3, 2. Those all are, and obviously these down here, those are repeating. So this is not a function. And then over here, if we have vertical lines, if it touches here and here, okay, that vertical line means that this is not a function as well. So you're looking for relations. Relations mean that domain is your x's and range is your y's, and you're looking for mapping those in different ways. And you're going to make sure that they're in fancy brackets, not repeating, and then you're going to make sure that you're looking for functions, meaning that they are not going to repeat x value.